Hi, and welcome to the second day of camp. Today, we're going to be building on what we've already learned by working our robot through a maze. To start off with, let's look at this backdrop here. We're going to switch our backdrop from the current field to this first little maze-looking thing, just to get started. And then we're going to go back to the code from our former sprite. First, let's get our workspace ready for new code. We can keep our old code by just detaching it from the green flag block, which will keep it from being run when we click the green flag. So as we can see, it's not turning or pixelating anymore when I click the flag. Or if we want to clear up our area for new code, leave it a little less dirty, a little bit less clogged with old code. This can become more important with the more and more code that you're going to be creating throughout the camp. We can use our backpack. So if you drag a block into the backpack, it'll save it, and you can see it down here. And so now we can throw this block away without worrying that we're losing our progress. It can be good to keep some of your old code ideas around so that you can use it later, but we don't want it really clogging up our space. It might make it a little bit more confusing to work on what we're currently doing. So our current project is programming our robot to go around the black line. So we want it to move out here, and then go over here, and then finally come back down here. See if you can figure it out. You can use coordinates or steps, but I'm going to ask you not to just teleport your robot, for the sake of reality. If we were in real life, we wouldn't be able to just pick up our Mindstorm and plop it down 10 feet away. Pause the video now to try it on your own. Okay, now let's compare your code to mine. I used steps and degrees. I experimented and figured out that I had to move the robot 300 steps forward to get it past the black line. Then I had it move 90 degrees clockwise, which turned it to go in this direction before having it move another 300 steps. Finally, I had it turn another 90 degrees and then finally move another 300 steps. I also added in these white blocks, and these blocks at the front that tell it its initial direction and its initial coordinates. So first, let's see what happens if I don't use my white blocks. So these aren't doing anything. It looks like it teleports, right? I didn't really like how that looked because I wanted to make sure that my robot was actually doing these steps in order. I wanted to make sure that my code was doing what I wanted it to do. And so I added in these white blocks so that I could see it doing each step. And I added these initial direction blocks here because I want my robot to go back here automatically when it starts. I don't want to have to drag it. That's a lot of work, and having it start in the same place every time allows me to be precise with my measurements. So now let's see what it looks like. Now we can see the robot moving from step to step. Okay, so we accomplished the task, right? But how can we make our code more simple? Right now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different blocks of code. Can you see where we can make this more simple? If I look here, this looks exactly the same, right? It looks like I have 3 sets of the same blocks. And so we're going to learn how to make our code more simple by using a more complicated way that ultimately makes it easier. So we can see that my code is basically the same thing repeated 3 times. So we're actually just going to write it like that. If we go into the control category, we'll see a lot of different repeating blocks that we can use. Repeating blocks, also called loops, are just ways for us to repeat our code without having to write it out over and over. There are a few different types. A normal repeat block repeats a set of blocks a certain number of times. A forever block will repeat the set of blocks forever, so it's good to use if you need something to happen for an undetermined amount of time. You have to be careful to program in ways for it to stop though, or it might run over and over until it crashes your computer. Finally, the repeat until block will repeat a certain action until a criteria is reached. If you look inside the repeat until block, you'll see a diamond-edged space right here. This is where our stopping action would be placed. The block will stop repeating when this diamond block becomes true. If we scroll through the palette, we can see that there are a lot of options for this space. We could have our block repeat until it touches something else, or until a certain value is equal to another number. We'll talk more in depth about this when we talk about sensors tomorrow. Right now, we're going to use our standard repeat block because I know exactly how much I want to repeat this for. I'm going to take out our repeat block, change the number of times to 3, and put what actions I want to do inside of it. So I want my block to wait 1 second, move 300 steps, and then turn 90 degrees. Notice how I'm not putting these blocks inside the repeat block. Take a second and think about why I wouldn't want to do this. Right, because these are resetting where my robot is. If I have it reset every single time I want it to move, it's just going to bring it back to the start over and over. And that's not what we want. So we can see already that this is making our code a lot shorter. So it's easier for us to read. And it makes it a lot more adjustable. So first of all, let's see if it'll run right. And it does exactly what we want it to do. But if I were to want it to rotate another way around, then I could just add another set of rotations in. So if we have it repeat 7 times, it'll go around another circle. And it was way easier for me to change that number from 3 to 7 instead of having to add all of these extra blocks again. So that's where the repeat block can really be very helpful. Okay, so my code is working fine, but it isn't really doing what I want it to do. I added in the waiting time, so it didn't look like my robot was moving so fast I couldn't see its path at all, but I want to slow it down even more. In real life, I would be watching it move across the floor. I want to replicate that on Scratch. I'm going to do this by breaking down the step increments. Instead of doing 300 steps at once, it'll slow down the code to have it move 10 steps at a time. This is also where repeats become very, very helpful. So before, if I had wanted to do this, I would have had to write out 30 different blocks because to make 300 is 30 increments of 10. Now, I can use another repeat block to make life easier. I'm going to put another repeat block, again, one that has the number option, because I know how much I want to repeat. Inside this section here, we're going to take out my degrees, and we're going to have it repeat move 10 steps 30 times. So now, if I run the program, let's set this back to 3, just for simplicity's sake. I can see that it's moving. It's a little fast and stuttering, but I can change that by altering the step number again. Let's see what it looks like if I have the number of steps I'm taking at a time so that it is 5 steps. And that, of course, means that I have to increase this 30 to 60, because if we are having this, we have to multiply this by 2. Now if I run it, it's even slower and smoother. It looks almost like a real robot. So again, let's think about why I still have my degree block outside of my secondary repeat. If I were to put it inside, my robot wouldn't go straight. It would turn when it didn't need to turn. Let's see what that looks like. Look at that. So that's why it's important to understand which actions you're trying to repeat and which actions you want to kind of keep the same, or you want to only do once or twice. Repeats are a really good thing to keep in mind because it's really hard to write any long program without them. All right, for your next task, you're going to move this backdrop to this one. It's a little bit more complicated. We can already see that. Try moving the robot through this maze. So have it start here. We'll set our direction to 0 again. Try moving the robot through the maze without it hitting the walls, so these black lines here, or really teleporting. So I don't want to see code that's just go to these coordinates. I also want you to try to do this without using any if blocks or sensors. If you have previous experience with Scratch, you'll kind of know what those are, but I want you to try to do this manually. So using what we did here, we're figuring out how long it needs to move here, turning it, how long it needs to move here, and so on and so forth. Keep in mind, as you're working through this, how difficult it is for you to be doing this. Is it really easy as you're working your robot through these paths? Is it hard? Does it take a lot of time? Does it take a little time? We're going to be going over your results tomorrow when we learn about sensors, so stay excited. Again, if you want to keep your old code without it interfering with your new stuff, you can detach the event block here, and that will keep it from running. You're always welcome to put it in your backpack too to save it for later. Copying this old code can be a great way to get started on this new project, so feel free to keep it in mind as you're working on this. As always, if you have any questions, feel free to email me at frc5587@gmail.com. I'll be looking at your project and giving feedback in the comments too. See you guys tomorrow!